Alright, so here's the third video on finding where a function's increasing, decreasing, and relative max and min. Alright, so we want to find the open interval where the function is increasing and decreasing and relative extrema. Alright, so let's find where it's increasing and decreasing. So to do that, we need to take the derivative. Okay, so the derivative here we have to use we'll use the quotient rule. So remember, that's the derivative of the numerator, 4x cubed, times the denominator, minus the derivative of the denominator, times the numerator. And that's all over the denominator squared. And so I get f prime of x. I have to clean this up a little bit. So that is going to be 4x to the fifth minus 2x to the fifth minus 2x, and that's all over x to the fourth. And so f prime of x is equal to, let's see, that's going to be, what's that, 2x to the fifth minus 2x over x to the fourth. Okay, so there's our first derivative. Now we need to set it equal to 0 and solve for x. And remember, a fraction is 0 only when the numerator is 0. So all we have to do is set the numerator equal to 0 and solve for x. Alright, so here we'll factor out a 2x, and that'll leave us with x to the fourth minus 1 equals 0. And so that's going to be 2x equals 0, or x to the fourth minus 1 equals 0. So we get x equals 0, or x equals, now, well, let's just go ahead and solve this out. X to the fourth equals 1. And so we take the fourth root of both sides, so x is equal to plus or minus 1. Alright, so we've got our critical numbers here. And remember, there's also a critical number where the first derivative is undefined. And the first derivative is undefined at 0, okay, which we did get 0 here, but it's also undefined at 0. But look at this. Notice the function is also undefined at 0. So that tells us 0 is not a critical number. Okay? So our only critical numbers are plus or minus 1. So let's go ahead and make our number line and plot our critical numbers on there. Now, notice I'm plotting 0 on there. Now, what you need to understand, 0 is not a critical number, but I put it on there because it could change increasing and decreasing here. So, to find where it's increasing and decreasing, you want to set the derivative equal to 0 and solve, and you want to take those numbers and put them on the number line, and you also want to see where the first derivative is undefined and put that number on the number line, even though it's not a critical number. Okay? But the one thing we do know is 0, we're not going to have a relative max or min. Okay? But it could change increasing and decreasing. Alright, so now I need to pick numbers from each interval. So I've got x is -2. I'll choose x equal -1/2. And I'll choose x equal 1/2 and x equal 2. Alright, so when we look at this, we have to take the -2 and plug it into the first derivative. So we'll plug it in here. Okay, so we've got f prime of -2, and so when I plug that in, I get 2 times negative 2 to the fifth minus 2 times negative 2. So the numerator is going to be positive. Okay, the numerator will be positive. And you can plug it in and try it yourself. And then when we plug the negative 2 in here, that's going to be positive because it's raised to the fourth. So I've got a positive over a positive. That's positive. So that means, since this is positive, when I plug the negative 2 in, that means it's increasing on this interval from negative infinity to negative 1. Now let's plug in the negative 1/2. Alright, so when I plug in the negative 1/2, let me change colors, f prime of negative 1/2. Okay, so negative 1/2 to the fifth is negative 1 over 32. Okay, see, I'm not worried about the denominator. The denominator is going to always be positive because it's raised to the fourth. I just need to check to see what the numerator is. So negative 1/2 to the fifth is negative 1 over 32. Okay, and then 2 times negative 1 over 32 is negative 1/16. And then I plug the negative 1 into here, that's plus 1. Okay, 2 times negative 1/2, or minus 2 times negative 1/2 is positive 1. So negative 1/16 plus 1 is positive. So I have a positive over a positive. That's positive. And so that means on this interval, from negative 1 to 0, it's increasing. And then I will do f prime of 1/2. So when I plug the 1/2 in here, this is going to give me 1/16, and then plug it in here, that's going to give me minus 1. So 1/16 minus 1 is negative, so a negative over a positive is negative, so that's less than 0. So that means on the interval from 0 to 1 it is decreasing. And then we do the f prime of 2, and when I plug it into here, the 2, that's going to be a positive up here in the numerator and a positive down here in the denominator. And so that tells me that this is positive, so this is greater than 0. So that means on this interval it's increasing. Alright, so now I have just noticed I made a mistake. When I plug the negative 2 in, that's going to be negative 64, and this will be plus 4. So negative 64 plus 4 is negative. So this is actually less than 0. So that means here it is decreasing. Sorry about that. Okay, I'm sure you probably caught it when I messed up. Alright, so now let's look at this. It is increasing. I'm gonna erase this so I can have a little more room. Alright, so here we are increasing from negative 1 to 0, and we're increasing from 1 to infinity. And we are decreasing from negative infinity to negative 1, and decreasing from 0 to 1. Okay. Alright, so now we look for relative max and mins. So you can see how here it's decreasing until it gets to x equal negative 1, and then it starts increasing. So this tells us we have a relative minimum here. And here it's decreasing, and when it gets to x equal 1 it starts increasing, and so you can see we have a relative minimum here also. And then here it's increasing until it gets to x equals 0, and then it starts decreasing, but there's not a relative max there, okay, because the function is undefined at 0, okay. But just like I told you, whenever you're finding where it's increasing and decreasing, you want to know where the first derivative is 0 and where it's undefined, okay. But remember, down here, these are your critical numbers. This x equals 0 is not a critical number, but we still use it because the function could change increasing and decreasing. Sometimes it will, sometimes it won't. It just depends on the problem. Alright, now we need to find our, well, in this case we only have relative minimums. So our relative minimum, okay, we have one at x equal -1. And let me erase this so I can work it out here. Alright, so we have a relative minimum at x equal -1, and now we need our y value. So to find the y value, you take your x value, plug it back into the original function. So f of -1 is -1 to the 4th plus 1 over -1 squared, and you can see that gives us 2. Alright, and then we have a relative minimum at x equal 1. And if we plug the 1 in, we're going to get the same answer, 2. And so here's where it's increasing, decreasing, and in this case we only had a relative minimum. Alright, so sorry about the mess up earlier in the video, but hope it helped. Don't forget to like and subscribe. Alright.